have my calculator out. I would have it on. Again, on the day of the AP test, I'm going to give you a backup calculator. So if you're using yours and it's like running slow, you can have a second one next to you just to like have, or batteries die or something. You will have two calculators. So what it says is it starts with at 5 a.m. to 10 a.m. So we have a time interval. And it gives us the rate at which the vehicle arrives at a certain toll plaza is given by. So we are given a rate. So again, it's kind of like being given a derivative. So we want to treat that as like the middle function. $5 a.m. is like hour 0, because it says that we are talking about number of hours since 5 a.m. So it would mean 10 a.m. is like t equals 5. A of t is measured in vehicles per hour. So it means its derivative would be vehicles per hour. Traffic is flowing smoothly at 5 a.m. That smoothly is their way of implying that the function is continuous and smooth. Part A says write, but do not evaluate an integral that would give the total number of vehicles. So if I'm trying to get rid of per hour and I want number of vehicles, then I need to integrate and go backwards. So for part A, we would be creating an integral. That integral would be of A of t dt, because that would give me number of vehicles per hour. It wants you to go from 6 a.m. to 10 a.m. So we are integrating from 1 to 5. That was worth 1 point on the AP exam. I almost could have gotten that point, right? Okay, so scoring wise, it said that the response must be a definite integral, meaning you had numbers at the beginning and end. You could not have the absolute value. And you did not get your point if you did not have dt or dx. Repeat. Find the average value of the rate and the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza. So if I'm finding the average value of the rate, am I finding the slope of the secant, or am I finding the average value of the integral? We're doing A of 5 minus A of 1 over 5 minus 1, or we're doing the integral from 1 to 5 divided by 5 minus 1. What do you think? Okay. Versus? What? You said the secant. That was the first one. So average value of a rate, they integrate. Average value of a rate, they integrate. Then you go to your calculator. And that's 9. So if you just found the integral, you got 1,502.1476. But you have to divide that integral by 4. And you got 375. .5369, and then it says find the average value of 3 and how much vehicles per hour at which vehicles arrive. So it doesn't ask you for it, but I am more than likely going to explain or just add to it that the average rate So the other thing is it asks you to find vehicles per hour. So if we integrate, we got vehicles. We knew that from part A. So if integrating got me vehicles and I need vehicles per hour and I need average, then that was another way you knew it was the integral. Because if you did the slope of the secant for A of t, then what you would have had is vehicles per hour minus vehicles per hour all over hours, which would give you the average acceleration or the average of cars, vehicles per hour. So sometimes just writing out the units is helpful as well. Is the rate at which the vehicles arrive, increasing or decreasing at time 1? So again, go back to our days. How do I know? So we're looking for A of t. I want to know if A of t increasing or decreasing. So if you want to know if a function is increasing or decreasing, what do you look at? You look at its, if the derivative is positive, then the function's rate is increasing. If the derivative is negative, then your function rate is decreasing. So we would want to look at A prime of 1. So again, go to your calculators, hit math 8, put in dx, put in your function. And then evaluate at x equals 1. And I get 148.942. So that tells me A prime of 1. That gets me 1 point. The second point for this problem is earned by describing this in calculus terms. So my justification is for giving my reason. So A prime of 1 is equal to 1. And then I would say, I saw the flash. So if a prime of 1 is a positive value, then you would put for your justification that the rate at which vehicles arrive, the rate at which the vehicles are arriving at, and you could put either t equals 1 hour or at 6 a.m. is increasing because a prime of 1 is greater than 0. So again, it goes back to the nut, right? Now, rate at which they arrive, units, 6 a.m., greater than 0. Good. So that was worth 2 points. And then part D, a line forms when A of t is greater than or equal to 400. A line forms when the rate at which the vehicles enter is greater than or equal to 400. The number of vehicles in line at time t from A to t to 4 is given by the following function, where A is the time when a line first begins to form, to the nearest whole number. Find the greatest number of values of the number of vehicles in the toll plaza from A to 4. So, what are we setting up? We are setting up E, B, T. It's an EBT problem because we need a table and we need values in our table and we need to start and end our endpoints. So we know in that table we for sure need an A and we for sure need a 4. What we don't know is what we need between A and 4. This is also a fundamental theorem of calc. Right? It's a fundamental theorem of calc because you have A, which is non-numeric, to times t, so the value of that highest point is going to be coming from the idea that how do we find our extreme values? So I told you this is EBT. Where do the extreme values occur that are not our endpoints? They occur when our they occur when A prime of t is 0. Or in this case, since our function is n, it would be when n prime of t equals 0. So therefore, we need a derivative. So derivative of n of t is n prime t. Only because I'm running out of room. The derivative of the integral tells you that you take the top number and you plug it in, right? A represents a constant. What's the derivative of a constant? So it's 0 away. So we end up getting our derivative is equal to A of t minus 400. And we need to know when n prime is 0. So ultimately, we need to know when our original function is 400. So again, you have your original function, ny1. And you should get 2 points of intersection. So what I do is I change my window. So I make my x's 0 to 5, and I made my y's negative 390, positive 390 to 410, so that I really only had to graph that 400 line and then what was happening around it. So you would do your second trace intersect. So you got, this problem was worth 4 points. You got 1 point for doing this part over here. A would be equivalent to that starting point, since we didn't know what A was. So if you think about it, how are you going to get 0 with an A? Or how are you going to get that 400? So that would be if your interval went from like the same point to the same point. So my A is going to be equal to that first point we find of our intersection, the midpoint, and then the end point. So then the last thing you have to do is, these are your times. Now I need to find my end. Because I'm looking for the max. And the max can only occur at any of those 3 points. So then you would go to your calculator one last time. And I would go math 9, 1.4693. And obviously if you do 1.4693 to 1.4693, we're going to get, and then you're going to do 1.4693 to 3.5977. And then it's A of t, which is under y1, so you get vars function y1 minus 400. Or minus 5. And go back up, copy and paste, and do it again, but to 4. So your second point came from finding the two red numbers. Your third point comes from getting this 71. But again, remember it said whole number. So it says find the greatest number of vehicles on the plaza. Make sure your answer is a whole number. So the final thing you would say is that the greatest number of vehicles in line is 71. They consider the table your justification, which would earn you that final point. Like the table is kind of worth 2. That's worth 1. I mean, I must feel like we could have done everything but for D is usually the hardest part of every problem because it's the build-up. So again, taking into account A is 1, B is 2, C is 2, you could have earned 5 out of the 9 points. So I always tell kiddos, like, do the easy parts and then go back and try or attempt. It's okay to be wrong. And worst case scenario, like you earn some random point